Hi there. I decided to choose my topic on the Serpentine River. I am going to be examining the area of the Serpentine River near the Van Dyke Trail. The Serpentine Van Dyke Trail is near a marshy area where it passes below King George Boulevard. The Serpentine River originates its groundwater flow in North Surrey. The Serpentine River starts in North Surrey at an elevation of 76 meters and flows southeast towards Steinhead Park for another 7 kilometers. And then it heads southwest, which is the longest stretch of 22 kilometers towards Mud Bay, and eventually flows in the Strait of Georgia, which flows into the North Pacific. The Serpentine River has a watershed catchment area of 116 square kilometers and a length of 35 kilometers. The river receives its high surface runoff from impermeable surfaces in urbanized areas. The geology is primarily composed of marine clay, and it has obviously the underlayers of alluvium, fresh water, the cap rock layer, as well as saline water. The upstream areas are composed of the Newton-Clayton area, as well as areas of Guilford, and as it flows downstream, it's composed of the agricultural land zone. River is a meandering river. It starts from here in Boundary Bay. This is where I am going to be showing you near the Serpentine Fen. The river starts towards Boundary Bay, empties into the Strait of Georgia, comes up along here toward the Serpentine Fen, up towards Headstream, in Tynehead and Fleetwood area, and then further continues upstream all the way towards Steinhead, where it begins as a creek. The river system is comprised of a drainage basin and watershed where its tributaries meet. The water enters the delta via surface flow and subsurface flow. Its tributaries, which include the Latimer Creek, Mahood, and Highland Creek. The river is adjoined to an engineered straight channel which can be seen right over here, where there's the Oxbow Formation towards 160th Street. The channel type is alluvial and consists of mostly lowland elevation. Hi there, today I am at the Serpentine River. I am going to be showing you the part of the Serpentine River where it meets the Van Dyke Trail. As you can see, I'm examining the part of the river that bends below King George Boulevard and towards the ALR lowland farmland. The Serpentine River has a catchment of approximately 160 square kilometers and has a total length of 35 kilometers. The primary material of the bed is stony marine earth clay. So as you can see over this side, this is the Serpentine Wildlife Management Area near the Van Dyke Trail. And this is where there's a lot of waterfowl and migratory birds. So it's dedicated just to the plants, fishes, and habitats. We are located right over here, and where it shows over here, and this is King George Boulevard, and this is the river. And as you can see, it has a meandering shape, and these are the trails around here. And now towards the end of the river, where it enters into the delta at Mud Bay. So the river empties into the Strait of Georgia. The river changes its gradient under the decrease in the meandering as it flows outwards towards sea. Channel type is alluvial and meandering, and it consists of several curves along its course. The Serpentine River has a very low floodplain of approximately 0.015%. The river is not braided, and it is separated by point bars. It is not located at a steep slope and does not contain very high sediment at the fluvial plains. Precipitation or rainwater is affected by the infiltration, evaporation, and surface runoff when reaching the ground. The groundwater aquifers is poor in unpermeable areas due to urbanization and concrete surfaces, and hence evaporates in the atmosphere or runoff in other tributaries, including ditches, creeks, and ponds. The lowland areas are not being drained due to low water tables and ground aquifers. Water is likely to sit on the surface or follow other channels. The precipitation in Surrey Newton has an increased discharge rate from September to January. The highest precipitation is seen in November, and the lowest is seen in August. The average is 1,200 millimeters in lowlands and 1,400 in headwaters at Guildford. The majority of the rainfall happens during the months of October to May, and summer rainfall is only about a total of 40 millimeters. The temperature or daily average has an increase from January to August. The highest temperature is seen in August, and a decrease of temperature is seen in the months of September to December. The lowest temperature is seen in December. The temperature range is moderate and ranges from 2 degrees Celsius in January to 17 degrees Celsius in July. The maximum temperature is at 23 degrees Celsius, whereas the lowest temperature reaches 1 degree Celsius. The climate zone of Surrey B. The climate code is CSB. The average daily temperature of the 4 warmest months is above 10 degrees Celsius, and a general maximum of 22 degrees for the warmest months. Precipitation rate is 70% during the winter seasons from September onwards to February. The long-term discharge rate can be seen above. Discharge is fluctuating vastly between September and May to September is low discharge, and therefore there's drier rivers. There is no discharge or rating curve levels that could be found online, and hence there are some missing points. There is an increase in discharge towards the Mud Bay, and there is a higher flow rate near Fen Dyke. This is due to an increase in gradient and velocity downwards from steeper gradients and slopes. The discharge has an increasing flow velocity up to the peak and a decreasing flow velocity downwards. The graph shows increasing water in summer, decreasing in winter months. The channel is controlled by spillways and sea dams, and therefore the hydrograph as shown may not match the climograph. The mean annual volume is approximated to be double in the Serpentine River. Serpentine River experiences low flow in August, which is why there is insufficient needs for the agricultural farmers. The vegetation is primarily berries and grassland. Along the dikes, trees were replaced by natural grasses. The soils in the floodplain are of much lower pH and are minerally deficient. The soil is composed mostly of glycosis, mycosis, and humicosis. Much of the natural spawning has been lost due to erosion and siltation. There is a decrease in most common of the salmon population and trout population. Some spawning is still present in its tributaries of Serpentine, including the Mahood, Highland, and Latimer Creek. Several salmon species that have been decreased include the coho, the samo trout, the stickleback, the pricky scalp, crayfish, and as well as frogs. The Van Dyke is a floodplain and is essential for wildlife such as waterfowl and aquatic birds. Here's a video showing further landscape of Serpentine River as it approaches Mud Bay. There is harvesting of algae around the river bed. The river is composed of algae bloom. The water level is quite low in the summer. Due to these pesticides, the river is being actively checked for COD, which is chemical oxygen demand, the total organic carbon, the ammonia, nitrates, and nitrogen and phosphates, as well as the chlorophyll. The vegetation of the Serpentine River is primarily berries and grassland. The dikes and trees were replaced by natural grasses. Much of the natural spawning has been lost due to erosion and siltation. Most of the decreasing population have affected the salmon and trout population due to warmer temperatures in the summer months. The Van Dyke and floodplain is essential for waterfowl and aquatic birds. Due to recent human life activities, much of the natural trees have been cut and are being replaced with more grasses. Now I'm at Mud Bay, natural habitat for home to raptors, and it has natural grassland and is mixed with other migratory birds. It also does include coyotes. The river is considered to be surrounded by a lowland floodplain in the Guilford, Newton, and North Langley parts, as well as Port Kells, and is joined to Highland Creek, as well as its tributary Creek. The floodplain in the agricultural area causes high nutrient delivery to be delivered and transported down the river, affect the salmon as well as other wildlife in the river and aquatic birds. To prevent the vulnerability of floods, seam dams are located just below King George Boulevard. The dams have been relocated west of Highway 99. This is to better allow for fish migration and agricultural land protection. The Serpentine River has an aquifer below the agricultural land reserve. The aquifer is approximately 194 square kilometers in size and is confined aquifer, which is composed of artesian wells. The subsurface that is mostly composed of clay, making it less prone to infiltration and contamination. The water is recharged by groundwater flows from uplands to lowlands. The region between Mud Bay and Nicomel River is poor aquifer. The coastal floodplain composes of 20% of Surrey's land, and it extends from Boundary Bay to Cloverdale and Newton, up towards Steinhead. It is prone to floods from high tides and excess precipitation or storm surges from the Serpentine and Nicomel rivers. The flood system below is composed of sea dams, spillways, flood boxes, and pumps to mitigate floods. Surrey's floodplain is composed of dikes to prevent the flooding from seas. These can be seen along White Rock border as well as along the pump station and areas where the river meanders. The spillway is similar to dikes, which is in lower elevation relatively and allows water to be stored until the water level decreases. The ditches work according with flood boxes and pumps to move water from dikes to rivers. The surface water enters tributaries such as ditches, which is fed by gravity. In high tides, the pumps push the water to sea and the river as necessary to prevent overflow of water. The drainage pond located by the Fan Dyke Trail is primarily for flood mitigation and contamination into the wildlife habitats as well as downstream. Here is an example of one dike that we have by the Serpentine River. The spillway is similar to dikes. As you can see right there, the water due to pressure is stored when the water level rises and is released when water level decreases in the summer. Released by gravity when water levels are low. In high tides, the pumps push the water to sea and at the river. Here is an example of a pump station. Example of a pump right here. So this helps mitigate the water when water levels rise from the sea. So this is an example of a spillway. So it's similar to a dike, which is lower in elevation, and basically water is stored in there, and when the water levels are low, the water is released. These help push the water to the sea and river as necessary. There is a spillway located. So this has helped mitigating floods and allows the migration of salmon. So I showed you before the area located near Fan Bay, and this is the delta where the river flows out towards Mud Bay, out towards into the Strait of Georgia and the North Pacific Ocean. Elevation of near around the river is relatively flat and lowlands compared to upstream, as you can see that way, towards 30 Newton, up above the mountains. The dam is located underneath King George Boulevard. The gates close according to the gravity as tides rise to prevent the entrance of salt water, and then as tides lower, the gates open. The sea dam consists of these gates, which are approximately 3.2 kilometers from the mouth of Boundary Bay. Its primary function is to allow fresh water to flow from Mud Bay and to prevent the overflow, as well as prevent saline water from traveling upland into the streams. Also provides protection to the agricultural land area and is often open for longer periods during the summer and the beginning of fall. The sea dam is located at the mouth of the Serpentine River. You can see that these gravity-fed gates close as the tides rise to prevent the entrance of the salt water, and they open as the tides levels decrease. The sea fresh water is allowed to enter the bay from the mouth at Boundary Bay once gates open. This gate is open for longer periods of time during the summer, such as now and throughout fall. The river is at a low land area and it is at the same level as the tidal zone. Since the 1990s, many dikes and pump stations and sea dams such as this were constructed to further mitigate the vulnerability to floods. The elevation of the Serpentine River is relatively flat in the lowland areas. The primary land use is composed of agriculture, and hence agricultural diking has caused low water velocity and higher temperatures. The current industrial operations have allowed for wastewater to enter in the past, as well as the entrance of PCBs, which are polychlorinated biphenyls in the river. Near that way, the Oxbow Formation, there is a trellis pattern. This is caused due to the resistance of rock. The gravel in the bed load and sand have a higher flow than the suspension load with higher velocities. Is a floodplain figure that I was able to find, which estimates the 200-year future flood levels. As you can see, the flood levels are quite lower down towards the floodplain, and upland, the flood levels are higher. The numbers above the circle indicate the previous floodplain flooding level, and the numbers below indicate the future flood levels. The areas in red are shown to be the areas which are prone to higher flood levels. The flooding is a result of several factors. These factors include the volume of rainfall, the time variant that it takes for the water to flow from Mud Bay towards Serpentine in a storm event, the hydraulic responses, as well as the infrastructure to prevent, such as a sea dam and the relocation of the new sea dam. As you can see here, this is just a diagram showing the water flow and discharge. So precipitation is the input that flows various paths such as intersection and vegetation, and it also moves downstream through the land through fall and the stem flow, and thereby it infiltrates the soil or it overflows the soil. Otherwise, this precipitation is evaporated into the atmosphere, and the water enters the groundwater via river flow or leakage through aquifers, and therefore the output levels or discharge levels are controlled by sea dams. In addition, urban runoff has contributed to the stream temperatures as well as higher deterioration levels in aquatic life. It has caused basically a deficit in oxygen, as well as reduced agricultural farming abilities due to the contamination and less opportunities for recreational fishing. The water quality is very high in chloride, sulfate, and sodium, making it unsuitable for livestock or irrigation. Additionally, there are high arsenic concentrations. The first figure shows the fluvial features traveling from upstream to downstream, and the second shows the flow, which is called a helicoidal flow, as it forms the point banks and the slip-off slopes. This depositional landform is called the point bank, which is formed at the cause of sediments eroding from the cut bank slide. The sand and pebbles cover the inner side of the point bar, and the water flows according to this helicoidal motion, which causes an hydraulic action to move the water particles downstream. The erosion or corrosion, as it calls, is lateral and vertical erosion. Flow instability is caused by turbulence and friction with the banks and the bed. The thaw leg causes higher flow to the outer side and again to the inner side as the river meanders. The base of the point bank is formed is considered to be of low energy. The cut bank, which is the opposite side, is considered to be of high energy, and the energy level relates the intensity of the current. The interflow is caused by infiltration, which then reaches the subsurface. And a channel network is initiated via sheet flow, which flows down two gradients to the watershed. They enter the tributaries, such as I mentioned, which includes the Highland Creek, the Latimer Creek, and the Mahood Creek. And the interflows are where the water is collected and flows down the valley. So that would be located up in Tynehead. The Serpentine River is formed by the transportation of loose particles and dissolution of soluble rocks. Water also flows backstream and causes headwater erosion. However, this is mitigated due to the sea dam located below King George Boulevard. The sediment yield is very mild as there is moderate flow of water, and the slope of the river is very low. There is higher stream discharge at higher elevations, which causes sediment to flow down into the Serpentine Creek and then flow towards down Serpentine River. Here in the picture of the left is a riverbed cross section. The flow of velocity is higher in deepened subsurfaces and near the middle of Mud Bay. This is due to increased friction from the banks. The thaw leg can be observed at the point of the river, which meanders, causing faster flow of water. Here can be seen is a bird's eye perspective of the river channel on the right. Erosion happens. Is the side with the higher energy, and the deposition side that is formed at the point bank is of lower energy. The necks of the river to become narrower, which forms these oxbow lakes. It can be seen in the lowlands where the oxbow formation is formed. This meandering loop is called the oxbow lake, at which the point bars can be seen where there is deposition along one end, causes a point bank to be formed on the side opposite to it. At the termination of the river, where the river exits the delta, there is a loss in velocity, causing sediment to flow out towards the Strait of Georgia, as seen in the right picture. The alluvial fan is where there's a change in gradient and decreasing in the meandering. The sea dam also affects the discharge and sediment transportation, which helps mitigate backflow and alters the base level and further future erosion. Lake. Alluvial and meandering. It is a network of winding channels and takes on a lot of curves during its course. The Serpentine River has a floodplain with a very low slope of approximately 0.015% and meanders through the ALR land, as you can see over there. To conclude what I've learned from this project, I have learned many things about hydrological features. Learned a lot about drainage basins and hydrological variables such as discharge, stream gradient, and base flow, as well as stream velocity. I was able to better understand stream erosion and sediment transportation, and how depositional landforms. Thanks for watching.